All right, this is part 3 of the immune system presentation. It is the conclusion of the immune system for 7th grade science. I hope that you guys have learned enough to make you feel like you know a little bit about the immune system, you know how our body works at an entry level, and I hope that you're interested to continue learning about it. All right, to start off, I want to talk about the history of immunity. Okay, so we're talking about immunity today, which has been a little bit different than what we've been talking about in general. So what we've covered so far is the defense system and how our immune system is the defense system. We have different ways that we battle viruses, bacteria, microorganisms, cuts, bruises, things like that. We have our first line of defense, second line of defense, and third line of defense. We talked about infectious diseases, and we talked about the organs that are part of our lymphatic system, our lymph nodes, our spleen. We also have our thymus gland, tonsils, things like that we've discussed. We talked about the different steps to the immune response. Now what we want to talk about is immunity. Immune, we think of immune, like how are we immune to different diseases? Okay, so that's what we're going to talk about. Some history is smallpox. Maybe you guys have heard of smallpox, maybe you haven't. It was one of the deadliest diseases known to mankind. I'm just going to read this, you can follow along. And it is also the only disease that has been eradicated. Let's stop there for a second. What does this word eradicated mean? Eradicate means to destroy completely, put an end to. That's the definition of it. Well, what does that mean when it comes to a disease? It means basically the scientists have come up with this word eradicate. And by the way, there's a game called Pandemic that's pretty interesting to play. And it's kind of accurate how Pandemic works, so I recommend it if you are wanting to play a board game. Anyway, this word eradicate means that we reduce the number of cases of this disease to 0. So in the world, there are 0 cases of smallpox at this point. The last known case of smallpox was in 1977, and that was in Somalia. So eradicate means that it doesn't mean that it's gone, that it's impossible to get smallpox, but what it does mean is nobody has it, so you're probably never going to get it because it's not going to be spread. Okay, so that's what eradicate means. So smallpox is the only disease that has ever been eradicated by the use of a vaccine. Now we're going to get to what a vaccine is a little bit later. Evidence of smallpox lesions date back to the Egyptian mummies, and it has been plaguing man ever since. So a long time smallpox has been a thing. Thanks to the efforts of Edward Jenner, smallpox is no longer a threat. In 1796, Jenner took pathogens from an infected person's skin and used it to inoculate an 8-year-old boy. Okay, so pathogens, remember, those are those little things that make us sick, bacteria, viruses, other microorganisms. So he took pathogens from the skin of an infected person, and inoculate means he is basically given that disease to somebody else, to an 8-year-old boy. Okay, so what happened was the child became mildly ill, so not very ill, a little bit ill, several days later, but then he began to feel better. After the second inoculation, so he gave it to him again, no disease developed. Okay, so he gave it to him again and nothing showed up. He was fine. So Jenner's work was the first scientific attempt to control an infectious disease with the use of a vaccine. So technically that is a vaccine. Today, many vaccines exist that help prevent a variety of infectious diseases. Okay, we have a lot of vaccines today. You guys have probably heard about some. So that is why we do it, for the hope of eradicating diseases. Okay? All right, so let's kind of jump into how it works. We need to go back to antibodies. I know we've mentioned it a couple of times already. Remember, they are the proteins that are made by B cells, and B cells are a type of white blood cell that are basically the guys that are part of the big guys that are part of our immune system. And these antibodies attach to specific pathogens and they mark them. So like a puzzle piece I kind of mentioned before, they are marking the pathogens so that our body can recognize them as bad guys, right? So here on my picture, the antibody, or here's the antigen, it is marking them. That way the antibodies can see, fit into them, and get rid of them much quicker. Here are the dead guys, right? They're going to die really fast because they are marked by the antigen. If they do not fit, if your antibodies do not fit, then it doesn't work, okay? So remember, they're the proteins, match specific pathogens. The antibodies are your way of protecting you from getting the same pathogen again. Once we have developed antibodies, okay, then if that same pathogen that has come and infected you before comes again, then in a very healthy person's body, in a normal healthy person's body, I should say, they will not get to you the same way, okay? Then we also have, once the pathogens are marked by the attached antibodies, they are attacked by all kinds of immune cells and proteins. So once they are marked, any kind of immune system cell can kill them, okay, or protein that are designed to find those antibodies, okay? And because your body can make billions of types of antibodies, you can be protected from billions of types of pathogens. So a fun fact is there are certain proteins in your bodies that attach themselves to the antibodies and they punch holes in the pathogens, and that's what destroys them. And then we talked about macrophages before. Remember the macrophages, they engulf the pathogens that are marked. And through this group effort, all these types of cells, teamwork, right? The body gets freed of invaders. So antibodies are very, very important to immunity. We're going to talk about the different types of immunity, okay? And then at the end, we'll kind of review all the different types. Innate, okay? Innate immunity is our first one. What does innate mean? It means natural, okay? So this is our natural immunity that kicks in whenever the body is attacked, whether it's the first time or the 100th time. No matter what, our natural innate immunity always kicks in. It doesn't even have to recognize the antigens to start to recover. Okay, so even if your body does not function properly and you don't make antigens or antibodies properly, you still have innate immunity, which is still going to fight some things. Okay, so what is our innate immunity? What happens when we first get attacked? What does our body do? Well, we get a fever. Okay, so that's my picture down here. You guys have probably all had fevers before. Why do we even get fevers? Why is this part of our immune response? Well, I want to tell you it is part of your immune response because you may think that a fever is a problem, and sometimes it is a problem if it gets too high, but there is a reason why your body's getting hot. What happens is your helper T cells, remember those are another type of white blood cell, they send a chemical to the brain and they say to turn up the heat, okay? Turn up the heat in your body. Why? Well, after your body's temperature rises, okay, maybe you have 100 degree, 101 degree fever. We call that a fever. And what it does is it slows the growth of the pathogen. Pathogens like a very specific temperature. If it's too hot in your body, well, guess what? They're not going to reproduce. They're not going to be doing very well. Actually, sometimes even the fever kills them. Okay? Another thing that it does is if your body gets really warm, these cells in your body actually thrive. The helper, that's supposed to say helper, the helper B cells and T cells actually multiply faster. So your body's white blood cells are multiplying faster and the pathogens are not. That's good. Okay, so sometimes you gotta let the fever run its course. Now again, if it gets too hot, then you have to watch it, but fevers can help. So even though it's an unpleasant, it is part of our immune response. Okay. Okay, and then you get inflammation. Okay, inflammation comes in 3 different stages: redness, swelling, and heat. And a lot of times this happens when you get a wound. Okay, inflammation causes redness, so you see redness, warmth, pain at the site of the wound. And the reason why it does that is because there's additional blood flow to the area. Remember, we need your white blood cells to go. These little purple things are supposed to be the white blood cells, okay? And what happens is we need those guys to go. We need them to fight the infection. So the blood is going to rush to that area. When the blood rushes to that area, it causes these things: the redness, the swelling, the warmth, and the pain too. The pain actually exists even without that, but it also brings the pain because it's out of ordinary. Okay, so I kind of mentioned that. It also walls off the infected area using molecules of protein to build a biological fence. Okay, that's really important. It's building a fence around the area. That way, if something bad happens to that area, it's just that area. Okay, it's not going to enter your bloodstream and make you more sick in the rest of your body. Okay. All right, I think that's it for this slide. Let me make sure. Yes. Okay. All right, so this, by the way, is called local inflammation. So inflammation, here's the injury, and here's the inflammation. Okay? All right, innate immunity, that's your natural immunity. Acquired immunity, okay? This is the immunity that remembers, okay? So the first time a pathogen invades, it takes the B cells about 2 weeks to make effective antibodies, okay? This is important because once we have the antibodies, then we're going to recover faster. So let me show you. In this 2 weeks, it's a long time. 2 weeks is a long time for these little guys to make antibodies. So because it takes a long time, that's why you get sick, because it's taking all this time to make antibodies. But next time the same pathogen comes along, your immune system is ready to protect you. Your memory B cells produce other B cells that make enough antibodies to fight the infection in 3 to 4 days. Well, if it can fight the infection that quickly, it actually is short enough of time for you not to get sick. So the same thing is happening both times. Your body is trying to attack it, but because you have memory cells and because your cells can reproduce fast and know what they're doing this time, it prevents you from getting sick. And here's my little picture of these guys, okay? These memory cells that know what they're wanting, they know what they look like, so they're going to find them a lot easier, okay? That's a really good visual. I know it's kind of a funny cartoon, but it is a good visual, okay? They're able to see what they're looking for, okay? This is also called herd immunity. I don't know if you guys have ever heard that phrase, herd immunity. When you get sick, you actually have immunity from that same thing you've gotten sick with before, okay? In addition, just a side note, your T cells can also become memory T cells as well. Not just the B cells, the T cells can help you protect the next time you come in contact with the pathogen. All right, so we have innate immunity, and then we have acquired immunity, like you get sick before, and then you know after you get sick, okay? All right, active immunity. Now, these are not different. You can have active natural immunity and then active artificial immunity. So we're going to go through them. This is the immunity that results from the body's own B cells making antibodies to fight an infection. Okay. So natural active immunity is acquired immunity from a previous exposure to a disease. Okay. So I know that this sounds exactly like what we were just talking about, and it is, okay? But this is, so natural active immunity is our immunity that is required from a previous disease. This is our own body making the immunity, okay? We are going to talk about our own body, or getting immunity from something that's not our own body, and then it'll make more sense. But this is, active immunity is our own body. So we can have natural active immunity, which is we are getting immunity from something we've already been exposed to. So acquired We acquired the immunity from something else, and our body has become immune by itself. Okay, another way is artificial active immunity, and this comes from immunizations or vaccines. Okay, so when we get a vaccine, then our body, it's artificial because somebody has given it to us. Okay, we didn't just naturally contract it, but once somebody has given it to us, then our body does develop immunity by itself. Okay, so immunizations or vaccines is the disease that's given to us in a small form, and then our body develops immunity from that. Okay. All right, we're going to take a pause and talk about vaccines. Vaccines are a substance containing antigens that is injected into your body. Okay, so those antigens that are very, very special, that we need, that mark the disease, we actually can give that to you in a vaccine. Scientists have developed a way, and probably most of you have gotten vaccines in your life. You probably just don't remember them. What they do is they stimulate your body to develop antibodies and memory B cells to fight this disease if you're ever exposed to it. So it's the same thing your body does if you get the disease, but this way you don't get sick when you get it because the antigens either come from a dead microorganism or they have been modified to not hurt you that much. So you can get a vaccine, for example, like measles, mumps, rubella, things like that, and you don't actually get the disease. You don't actually get polio if you get a polio vaccine because it might be a dead microorganism or modified in a lab so that it's actually not that potent, but your body will still treat it like it is, and then it'll develop an immunity against it. So if you ever were to come in contact with it in real life, then it knows how to fight it and you don't ever get sick. Okay, well, what's the deal with booster shots? Maybe you've heard of booster shots before. Why do you have to get multiple shots of the same thing? And it's because it stimulates the memory cells to develop even more after the first injection. So this results in more antibody production, and then even more memory cells are made, so that actually guarantees the immunity. It's for something that maybe they give it to you and it's a dead microorganism, so your body only makes a certain amount of memory cells. Well, then if they give it to you again, then your body will make more memory cells and then more memory cells, and then it's ensuring you won't get the disease. They do that with a disease called Tdap. There's multiple different diseases in there, but it's like diphtheria, something percussious. I don't know exactly what it is, but it's really important, and you actually get boosters. You get the first one when you're 2 months, and then boosters when you're 4 months, 6 months, somewhere between 15 and 18 months, and then 4 to 6 years of old. So they just want to make sure you never get those diseases, okay? All right, the last kind of immunity is passive immunity, okay? So this is what I was talking about. There's a difference between active immunity and passive immunity. Active immunity was where your body will make it for yourself, okay? Passive immunity comes from somebody else's antibodies produced. So somebody else produces antibodies and then gives it to you, okay? The first one is natural passive immunity, and this is only one way. It's when an unborn child, there's actually 2 examples of it, but both of them come from mother to child, okay? So either the baby so if a mother's pregnant with the baby, there's something called a placenta, which is an organ that develops in a mother, and it basically, food goes from the mother to the child, but also immunity goes from the mother to the child. So that happens before the baby's born, and then when the baby is born, the baby can also get immunity from the mother's milk if she nurses the baby. Okay, that's natural immunity. These are antibodies passed from the mother to the child. Okay, and the baby is not making them for themselves. The mother is making them and then passing them to the child. Okay, it's actually a very amazing thing. And this actually helps the baby when it's very, very young and susceptible to many diseases. The mother actually is giving her immunity to the baby. Okay, it only lasts for a few months of the child's life, but it protects them. Okay, the other kind is artificial, and this is antibody transfer. So somebody else or they've made antibodies in the lab, and you give them to somebody that's already sick. The example is a rabies treatment. If you get rabies, this is how they're going to treat you. They don't actually like treat you and make you feel better. They treat you by giving you antibodies. Series of injections so rabies, if you don't know, is a disease that comes if you have an animal that an animal bit you that also has rabies. And what they do is they just give you these antibodies, and then your body is able to make them quicker and fight the disease quicker. So this is really the only time. There's another time as well, but it's really the only time when artificial passive immunity is given to you. So again, the difference is the antibodies are created by somebody else. Like the antibodies are created by the mother or a lab, and active immunity is when you create the antibodies. Okay, so let's kind of look at the chart here. Okay, so immunity, and there's multiple different types. Okay, there's acquired immunity and innate immunity. Remember, acquired immunity is when you have to have the disease before, right? So acquired, a pathogen, there's previous contact. Acquired immunity comes from a pathogen that has previous contact. You've had it before, you have to have it again. There's two different types of that. There's natural and there's artificial. Okay, so the natural acquired immunity, you can either get it maternally. Maternal is like mother. You can get it from your mother, either before you were born or if you were nursed. And then active from a previous infection. So natural, acquired, active immunity. It's a mouthful. Basically means you've gotten a disease like chicken pox. Maybe you got it before. You won't get it again because you had it. Okay, so that's what acquired, natural, active immunity is. Okay, and then we have acquired artificial, and this would either be through an antibody transfer, like the rabies treatment, and it's artificial because it's made in a lab, or an immunization or a vaccine, which are the same things. Okay, and that is acquired artificial active immunity, which means they give you the vaccine of the disease, and then your body has to make that antibodies for yourself. The last one is innate immunity, and that one's different than all the other ones. Remember, that's just like the fever and the inflammation. Okay, so that is the review. It was a lot of information. I hope you guys were able to kind of follow that. If not, I'm going to be posting the PowerPoint so you guys can actually flip through them and be able to kind of slow it down if you need to. All right, I hope you guys have learned at least a little bit about the immune system, because it's a pretty amazing thing. We can thank God for our amazing bodies that He's given us.